I'm going to go through problem 10 with you right now, which is asking you to find the perimeter of the polygon. First thing, when you are given vertices like this, so for number 8, you're going to have to come back and pretty much do the same problem here. You're going to graph the lines, which I'm seeing right now that my line went away, but that's all right. Let's see if I can do this here. Draw. I'm going to draw a new line for my x-axis so that we can see that. So, I think I had it, oops, dang it. I had it drawn in here. Let's try that again. Alright, it's liking what I'm doing. So, this thing. Anyway, okay. My x-axis is supposed to be right here. It's not supposed to be crooked like that, but you can see that I've got my points drawn for x, y, and z. And the deal is, for perimeter, remember that means the distance around the figure. And so, the distance between 2 points, we can use the distance formula, which you learned in 1.3. Okay? Now, on some of these, we're able to, like for x, y, right here, we're able to just count because it's completely vertical. So I've kind of gone down here and already done that. So since xy forms, I should say forms, a vertical line, we can count the units on the graph. On some of these, you're going to be able to do that. Like if I look at number 12, there's a bunch here that you can count. I can count, oops. Okay, I can count here. I can count this one. I can count here. I can count here. The two that I can't count are from E to D and from A to B. You're going to have to go in and actually use the distance formula for those. So I'm going to work through a couple distance formula problems because we can't do the distance, or we can't just count from x to y, and we can't count from y to z either because they form a diagonal line. So let's do that. Since y and z, got this written down here, since y and z form a diagonal line on the graph, we must count, or we must use the distance formula. Again, that distance formula came from 1.3. And I'm just going to do a refresher for you guys with this. So remember, zoom in here. My first step should be, I need to put my points. I want to label the values in my points. So this is my x1 and y1 point. We always have an x and a y. That's my first point. So that's why I'm using that subscript of 1. It doesn't really matter which point I pick as the first one, as long as I'm consistent with my numbers. And then this is going to be my second x and y. Okay, so I'm going to plug all of those values in over here. And the distance between x and y, I can just write xy. That's what that means. Without that bar on top, remember that's when we are using a value. We're using a number. So I'm going to use the distance formula. Every time I see a symbol, I need to write it. So my first step here is to go, all right, well, what's my x2 value? Over here, I labeled my x2 value as 3. Okay, so I'm going to come over and put 3. Then I write minus, because I see that minus sign right here. Okay, so minus x1, which I'm going to use green for that. My x1 I labeled over here as -1. And here's where most people mess up, because it is minus that -1. So I have to write the minus sign twice. So remember, algebraically, that means we're going to end up adding that here in a second. And then, let's use purple. y2. Well, y2 I labeled over here as 0. Okay, so I got a 0. And then minus, remember that comes from up here, my y1 value. So let's make this a blue. And no, I don't want to do that because my pen is blue. Let's make it pink. So y1 I labeled over here as 3. So 0 minus 3 squared. Alright, so now it's just a matter of a bunch of order of operations, which people mess up with all the time. So the biggest thing I can tell you is rewrite every single symbol every single time. So I got the square root symbol. We'll do 3 minus a -1, so +1 squared. Plus 0 minus 3, well I can go ahead and do that. That's -3 in there, squared. Okay, so now I've got 4 squared plus -3 squared. Okay, I'm going to erase what I got down here. I'll have to rewrite it here in a second. So, got my xy equaling, well, 4 squared is 16. -3 squared is 9. Okay, so remember, if I square something, I always end up with a positive. Well, 16 plus 9, I get 25. And the square root of 25 is 5. So the length of my xy, I'm gonna rewrite that over here. My length of xy is 5. Alright, so now, cool. I know that, oops, I meant this should have been, I apologize. This should have been xz here. So if I counted right here, I got 1, 2, 3, 4, 5 units. So xz is actually 5 as well. That's the one that we counted, not xy. So let me erase this. Oops. Wrong pen. Okay. So, we got two things that just kind of ended up that way, but this is also 5. Okay, now we got to figure out what the length of this is. This looks a little shorter. So YZ we need to figure out. Okay, so let's write our points again. Oops, I don't want X. Let's do, alright, Y is the point 3, 0. And Z is the point -1, -2. And again, I've got to find the length of it because it's a diagonal. It's not a straight counting point. So I'm going to rewrite my distance formula and start labeling and plugging numbers in. So here we go. I'm going to label this again x1, y1, and x2, y2. And now it's just a matter of plugging in. So instead of D, instead of distance, I'm going to just go ahead and write this as YZ, because that means the length of YZ. So my first thing I need to plug in here is X2. Well, we said X2 was -1. So -1 minus X1. Well, X1 here we labeled as 3. So minus 3 squared plus Y2. Well, Y2 we labeled as -2. And so we have -2 minus a y1. Let's make this, let's see, let's go back to green. And we want to minus y1, which is 0. Alright, now, and that's squared. So now it's just a matter of figuring out what that is. -1 minus 3, we get -4. -2 minus 0, -2. Remember, keep that in parentheses, because when we go to square it, if you plug -4 in your calculator and you square it without parentheses, sometimes your calculator thinks instead of this, -4 times -4, it thinks it's doing -4. Well, actually, what it thinks it's doing is, gosh darn it, what it thinks it really is doing is -1 times 4 times 4. And you end up with a negative. So make sure that you're using parentheses if you've got a number that you can't do in your head. So -4 squared is 16, plus -2 squared is 4. So we end up with square root of 20. Let's see. Do the directions tell us to round? No, it doesn't. So, square root of 20, well, let's see. That's going to give us, let me see what that is in my calculator. And let's see. I get 4.47 basically. So about 4.5. And so we end up with YZ equaling 4.47. Alright, so perimeter. Let's go back to that idea. That's going to be our lengths that we have found. So we needed x, y, plus the length of xz, plus the length of yz. Well, we got 5, 5, and 4.47. So 14.47 should be, and I don't know, I got to check Big Ideas and see exactly if it rounds or not, but you could try either one of those. So that's an example for problem 10 in your assignment. When it asks for area, you're going to do the same thing. You're going to graph those points. You're going to have to use the distance formula based on what kind of a shape it is. So in this one, I can tell right away we've got some kind of quadrilateral, so it's probably a square or a rectangle. This one, we got 3, so we're going to use a triangle formula for area. So you're just going to need to go back to your notes for area formula, and once you find the length of the sides that you need, you plug them into the area formula for, like for triangle, it's going to be half base times height. And then for whatever kind of quadrilateral that is, it's going to be length times width. And so you don't really actually have to find all 4 sides on those. You're just going to probably need to find 2. Alright, so let me know if you've got questions, and I'm going to embed this into the assignment as well. But remember, you need to do these assignments and then put them on, go into Big Ideas and actually submit them. Let me know if you've got problems. Bye-bye.